let's have be there have been a lots and lots of movies and books which have described the robots at various levels. Some have described and shown about simple bots, mechanical humans, humanoids, cyborgs, some simple robot toys and assistant robots and etc. So but what is actually a good robot? We need to think about it, because for good understanding we should look back how robotics was discovered and how the growth and development was there. So one must always look at the history and understand the evolution to move forward in robotics, not only in robotics but in every subject. So the word robotics was inadvertently coined by the science fiction author Isaac Asimov in the year 1941 in his one of the sci-fi and fictitious story called Liar. I have provided a picture over here, and I have read this book also. It is available in the internet all over for free, and I would really suggest you to read, because how this robotics idea came up for him is something very adventurous and was very eager to learn. So the ancient Greeks and Romans developed simple automatons and used them as a tools, toys, and they also included them as a part of religious ceremonies. So there have been many movies about this also, and you can Google it. So next, the in the Middle Ages, the both Europe and the Middle East countries were totally into Ottomans, where they were most popular as part of clocks and religious workshops. In Europe, there was an automaton monk extent that kisses the cross in its hands. Like it's totally something robot Christian who will be kissing out the crosses. So that's how the robots were used before, and they were even part of many religious ceremonies in European countries, in Greeks, and even long back when Romans were there. So during the World War, the meaning of robot was extended to include an automatic pilot, such as a farm as found in robot bombs. This was also the period of two related steps: the development of computer and the use of the first remote manipulators were there, and they were known as teleoperated robots or telekills. So hence, robot technology evolution dates from the back from Second World War, and in 1954, the first industrial robot was even built. And the first two industrial robot patterns were applied for, and it was the dawn of robotics age. Yeah, here is the image where you could see in the left first part where in the World War II, Germans used the teleoperated robots for bombing the US soldiers. And this is how this is the image depicting the soldiers viewing a new robot for the first time. As I said earlier, it's totally up to our hands whether we are going to use the robots for good deeds or not. So, anyhow, let's continue the history part, because I need to mention from in the 20th century till today, the robots have been in under a great extent of evolution. In mid 1950s, the German firm KUKA developed an automated welding line for appliances as well as for multi-spot welding line for Volkswagen company. And here is an image of KUKA robot used for multi-spot welding. And this was implemented for Volkswagen, the famous car company. The image is left below. So by 1968, Kawasaki has had licensed a Unimation design of hydraulic robot and had begun to build them. And in 1969, GM Motors, General Motors had achieved 90% of the body welds using Unimates in one of its plants. I'm sorry I could not provide you the Unimates picture, how it looks, the Unimate robot. So kindly note it down what and You name it, Robotics, and Google it and get the image. So for better understanding. So in 1970s, Stanford University, they developed so-called the standard robotic arm, as it is still known today, used for many small parts of assembling and incorporating touch and pressure feedbacks. Okay, just a second. I got a message. So for me, the history of robotics is only visible, and we are still in the part of history of robotics. And I hope I did not change the slide yet. Okay, let me change the slide. Okay, many were actually astounded in 2003 by the feats of NASA robotic robots, which is called as Spirit and Opportunity, exploring the surface of Mars, and you could see in the left below. By 2009, the development of autonomous industrial vehicles was well underway, and by the start of next decade, robotic arms were becoming mobile in industrial space. The year 2013 saw the introduction to collaborative robots, or so-called as cobots. Please do note it down what cobots there, and it is something important, and that's the next stage of robotics, and we'll be soon using it by our work site with every human workers. So over the last half century, robots have found a place in other spheres also. They are used as toys, as entertainments, as even a military weapons, and search and rescue assistance, and for many other jobs. Essentially, as programming and technology improve, robots find their way into many jobs that in the past have been too dangerous, dull, or so-called impossible for humans to achieve. But now it's becoming so possible, and robots are available. Several difficulties are inherent in many of these robot definitions. In the opinion of many individuals in the field, all current definitions of robots are too restrictive. The the main the definitions may have been satisfactory when they were adapted, but they had no provision to incorporate the changes in technology or application that developed, and thus the definition is now generally considered out of date. But as of now, there is no good definition or a paka definition for what a robot is. So the ISO and RIA, please do note it down. The ISO is International Standard Organization and RIA is Robotics International Association. So these two associations among with the other associations also recognize this as a problem, and they've been attempting to develop more up-to-date definition for a robot. Until a better definition is developed, we are gonna adopt Dr. Bizik's definition. There are three parts to technical definition of a robot. First, robots are generally general purpose mechanical machines. The second, they are programmable to perform a variety of work within the mechanical capabilities. And the third, they operate automatically. The term robot means different things to different people actually. Current definitions are reactive to past technology and do not address the issues of robot of tomorrow. It's the simple in more simple terms, definition of robot changes from time to time. They are not something universal until now. So each major robot association in the world has its own definition of industrial robot, general robot, and although similar, there are sufficient differences to cause confusion over what should be called as a robot for statistical purposes. These are few definitions given by Oxford University. The Oxford English Dictionary, sorry, the not a university, the dictionary. So they gives the following definition: a machine which is capable of carrying out a complex series of actions automatically, especially when programmable by a computer. This definition includes some interesting elements too. Carrying out actions automatically, this is a key element in robotics, but also in many other simpler missions called automata. The difference between a robot and a simple automaton like a dishwasher is in the definition of what a complex series of action it can do. So think yourself like, is washing clothes composed of complex series of action or not? Can we call a washing machine as a robot or not? So something a flying plane on an autopilot mode is a complex action. Can we call it as a robot or not? And also is a cooking bread by a toaster. It does automatically toast a bread, a toaster. So can we call it as a robot? We can't. So for all these tasks, there are missions that are at the boundary between automata and robots. So programmable by computer is the second element, because some automata are programmed mechanically and are not very flexible. On the other hand, computers are found everywhere. So it is hard to use this criterion to distinguish a robot from another machine. So a crucial element of robots that is not mentioned explicitly in the definition is the use of sensors. Most automata do not have sensors and cannot adapt to their actions with the environment. Sensors are what enable a robot to carry out some complex tasks. So it is actually always difficult to provide accurate figures to track the growth of robotics industries. For example, some sources do not distinguish between robots built and robots sold, and how much robots are being shipped, and how much robots are being actually installed and being working condition. So, in addition, since the definition of robots and the types of statistics reported change between countries, information gathered from the national organizations like ISO, RIA, and etc., cannot easily be compared. They could not get the exact details, though we have provided a few analysis which could be helpful. Because finally, some country organizations have corrected earlier released figures, and these corrections have not always been picked up in the literatures. The robotics market is segmented by types, I mean, the industrial and service types. The end users of industrial robots are automotive sectors, food and beverage companies, electronic companies, and etc. And the end user services of robots, service robots, are something in the logistics department and in military exercises and for defense purposes in the medical sector and healthcare and etc. So the global market for robotics is expected to grow at a compound annual growth rate. I mean, the compound annual growth rate is CAGR, and it is of around 26% to each just under 210 billion US dollar by 2025. So this is really a big number to be mentioned, and industrial robotics market, which has traditional represented the robotics industry and has been led by Japanese and European robot manufacturers. And they're giving away the to non-industrial robots such as for personal assistants, customer service robots, autonomous vehicles, and UAVs. I mean the drones. Anyhow, the automotive industry, which is considered to be most critical application sector of industrial robots, significantly increased investment in industrial robots worldwide. So back when I mentioned about the history, the Volkswagen was the first company to implement KUKA robots in them, and by today, as in April 2020, BMW AG has signed an agreement with KUKA Robotics for supplying of around 5,000 robots destined for new production lines and factories around the world. So there are many advantages of implementing a robot in factories and industries, and I'll be talking about it in the later sessions. So let's continue the modern world manufacturing sectors. So there are few main ways in which AI is deployed along with the robotics. Using AI subsets machine learning as a system is designed where the device learns from its mistake and automatically compensates for errors it works. So that's how machine learning is being used in robotics. It just makes the robot much smarter, and it makes the robot to think for itself and act according to the machine learning algorithms. Don't be confused or afraid of these terms, because I'll be soon explaining these terms to you, and I hope you all are still in the line with me. During this COVID-19, many technology has been playing a crucial role, and robotics is one of them. By assisting humans in containing the spread of the virus and dealing with the existing cases. One of the critical technologies that have made an enormous difference on the ground is, as I mentioned, robotics. A large number of hospitals worldwide are currently using robots to aid both the healthcare staff and patients. Robots have the potential to be deployed for disinfecting the room, delivering medications and food, and measuring vital signs and assisting border controls. So in China, the disinfection robot UVD was in the high demand since the outbreak of pandemic. So constraint. What is a constraint? A robotic constraint is a restriction placed on a robotic system that narrows its achievable motion possibilities. Constraints can include both the mechanical constraints and constraints of the whole system, such as joints that it has its limits, and constraints that have been applied by the users, such as the desired position of the tool or the desired position where the robot should move and it should not move. So the next important term is cobot. The term cobot is an abbreviation of collaborative robots. So I think I have already mentioned about cobot in the history. So this is an one of the important terms that we should know through through the addition of more sensors. A robot that was not originally designed to work with humans can enable collaborative operation in manufacturing environment, because we can't give everything to a robot. So by co-working with a robot, we can implement much more things than before. So the third term would be the end effector. It is also known as end of arm tooling or double E or EOAT. The end effector is a generic term that includes all devices that can be installed at the robot wrist. So the subsystem of robotic system that links the manipulator to the part being handled or worked on, and gives the robot the ability to pick up, handle, or otherwise interact with parts in the environment. So few examples of end effector are grippers and welding torches, etc. So the next would be the path planning. And pause for a minute, like I have mentioned few terms like manipulator, joints. What is the path planning? When programming a robot to perform a certain task, it is very often the case that the robot motions involved must not cause the robot to collide with itself or with its environment or with its tool or any other payload or any other roads. So that's the path planning. That's how the path planning works. Next, we'll be seeing about the many other important terms also. To start with, what is an algorithm? So while studying AI, machine learning, or even the robot languages, we need to understand what an algorithm is actually. So I know many engineering students are here, so they probably already know what an algorithm is. But for kids out there for studying 10th, 11th, 12th, or younger also, they don't understand what algorithm is. But let me explain. Let me at least try to explain what an algorithm is. Algorithm is a very simple term. It is actually a set of specific rules for the solution of a problem in a finite number of steps, which means it's nothing but actually a few number of steps we will be giving you, or we will be giving to the robot, and it should follow the steps in the order wise. So these are the rules which it should follow one by one, so that we could achieve a desired solution. I hope this explains clearly what an algorithm is. Next, a robotic arm. It is actually a robot arm which it is actually an interconnected set of links, and it is powered by joints comprising a manipulator which support or move a wrist, hand, or end effector. So, as I already mentioned, what end effector is, an arm is nothing but it connects the end effector, a hand, or a wrist. It is actually joined on with the manipulator's body. So, just make a note what a manipulator is. I'm going to tell in the future slides. So next, move on to articulated robots. So a robot arm which contains at least two consecutive revolute joints acting around parallel axes resembling human arm motion. The arc envelope is formed by partial cylinders or spheres. This would be most confusing, but make note of it. And by the third session, where we'll be discussing about the mechanisms of robot, I'll also explain what an articulated robot and how these joints and parallel axes or means. What means? Okay, now what is CAD and CAM? Oh, mechanical students could definitely understand what CAD and CAM is, but it is nothing but an acronym of computer aided design and computer aided manufacturing. This is CAD is a designing process, and we CAD in CAD the mechanical engineers used to design any kind of robotic part or any kind of joint or any kind of design is being done with the help of a computer software. So CV, we call it as a short term CV, and it is also known as mission vision. So the use of computers or any other electronic hardware to acquire and interpret and process the visual information is what a computer vision is all about. It is nothing but a camera. A camera is a simple example of a computer vision. Next is DOF. DOF is nothing but degree of freedom. Whomsoever learning robotics must understand what degree of freedom is all about. There's nothing but the number of independent ways the end effector can move. It is defined by the number of rotational or translational axes through which motion can be obtained. So rotational translation axes are nothing but the two different types of motions that can be acquired by any of the parts or any of the objects that exist in the three-dimensional world. So in our world, we can you just imagine your whole arm. You can move translational in the sense straight forward and back forward or up and down, and rotational means you can rotate your wrist, or you can rotate your fingers. So these are the different types of motion that you can do with your hands. The same goes for a robot's end effector also, not only end effector, any kind of part. So degree of freedom is nothing but the number of independent ways that any object can move. So this is a simple term. So in the third session, mechanisms of robotics, I'll be explaining clearly about what degree of freedom is. So haptic interfaces are nothing but devices which is controlled by human, uh, but through a physical contact. It's kind of where we are exerting some kind of force from a human body, and that has been interrupted by the robot, and it moves what it moves to the command that we are giving through the action using the force. And the homogeneous transforms, it is also important because uh, while doing the kinematics and design of robots, homogeneous transform is going to play a vital role. Homogeneous transform, it's a topic which comes under matrices, so you can learn in the math part. Manipulators is actually and one of the important terms which we need to understand. Because manipulator is nothing but it is a mechanism usually consisting of series of segments like links, joints, or sliding relative to one another for grasping or moving objects. It is usually in several degrees of freedom. Manipulator is nothing but a robot only, but without an artificial intelligence into it.